Hi guys, this is Miss Page and I'm going to do another video today, and this is pages 9 and 10, and pages 9 and 10 is the second student activity for TEKS 7.7a, and its topic is to represent linear relationships using tables. And on the other video I pointed out to you that the first formula on our math chart is the slope-intercept form of a line, which is y equals mx plus b. That is a linear equation, and you will see this so much while you're in this class for the rest of the year, but also like all stinking year long as 8th graders. So y equals mx plus b is a very important linear equation that you will see over and over again, and there's lots of different ways that we present this, like we did in the student activity 1, where it was just with words, and we were interpreting it into the numbers and operations and stuff that it was, and now we're going to put this stuff into a table. So that's going to be fun, and then we are going to be doing it on a graph and other things later on in the school year, but right now let's get busy with this. So the first problem says for us to complete the table below using the linear relationship equation y equals half of x plus 3. Okay, so we've got all of these values of x, 3, 4, 6, and 12, and they want us to figure out what y is. So they left this space here so that we could say 1/2 of x, which is 3, plus 3 gives us y, and y is down here. So half of 3 is 1.5, and if I add that to 3, that gives me 4.5 as that point. And then if I put this 4 in here, 1/2 times 4 is going to be 2, and then if I add 3 to that, that gives me 5 as my y value. And then for the next one, if I put 6 in there, y equals half of 6, and then I add 3 to that, half of 6 is 3, and if we add 3 to that, that gives me 6. Okay? Hey Harrison, go check in the hallway and see if there's a dinosaur in the hallway. I think there's a dinosaur in the hallway. I'm just telling you. Pretty sure there is. So y equals half of 12 plus 3. Half of 12 is 6, and if you add 3 to that, that gives me 9. So if they did ask us to graph this, you would have the ordered pairs 3, 4.5, 4, 5, 6, 6, and 12, 9. You could do it, but they don't ask us to, so we're not going to. Moving on, problem number 2 asks you to complete the table below based on the verbal description, and it says a longer piece of ribbon is 5 inches longer than twice a shorter piece of ribbon. So a longer piece of ribbon, that's what y is, and it's 5 inches longer than twice the piece of shorter ribbon. So twice, and we're going to call the shorter piece of ribbon x. And so the equation that represents this description is going to be y equals, and remember that commutative property that says, oh, I forgot to put my equal sign, sorry. That commutative property of addition says that we can switch around numbers that we're adding, and it doesn't make a difference, so we can put 2x on the left side and 5 on the right side. So y is equal to 2x plus 5. And if we fill that into here, y is equal to 2x plus 5, and it tells you right here that x is the shorter piece and y is the longer piece, and we're going to put the value of x in here, 2 times 11 plus 5. 2 times 11 is 22. Add 5 to that, that gives you 27. On the next one, 2 times 15 is 30, plus 5 gives me 35. 2 times 24 plus 5 is 48, plus 5 gives me 53. And then the last one, 2 times 30 plus 5 gives me 65. Okay? And again, we've got the ordered pairs, x, y, x, y, x, y, x, y. Okay. Problem 3. Write the equation that represents the linear relationship shown in the table below. And then it wants us to show our work to support the answer. Well, this one only gives us the values of x and y, and in order for us to figure out what else would go here, I'm going to write y is equal to mx plus b. Okay? So, to solve this, I'm going to put the 7 here because y is equal to 7, and we know that m times 3 plus a number b would give us what it is. So we could actually know that 2 times 3 plus 1 is 7, but also 1 times 3 plus 4 is 7, so we don't know what m and b are. How are we going to figure it out? Okay, that's where this comes in. You got to figure out k. Okay? Not k. You got to figure out your rate of change. Okay? The rate of change, remember, is the change in y divided by the change in x. And if I look at the change in y, that change is 2. And the change in x from 3 to 4, that is 1. Let me double check that and see if it works in other places. 7 to 13 is 6, and 3 to 6, that change is 3. So, that's looking like it's going to work. From 9 to 25, the difference there is 16. And from 4 to 12, the difference there is 8. So that means that our rate of change stays constant, and it is 2. So if I put that, sorry guys, just a second. If I put that in here, N for m, we know that y is equal to 2 times x, and if we add 1, we get these numbers work. Okay, 2 times 3 is 6, plus 1 gives me 7. Let's check and see if that works all the way across here. 2 times 3 plus 1, oop, it gives me 7. 2 times 4 plus 1, oh, it works. 2 times 6 plus 1 gives me 13, and 2 times 12 plus 1 gives me 25. It checks, it checks, it checks, and it checks. So, we have the right equation. It tells you to write the equation in the middle row first, shaded column, and then fill in the rest of that row to check your equation for accuracy. So I should have written this equation right here. Y equals 2 times x plus 1. We found the equation. Problem 4. If a linear relationship is represented by y equals 12 minus 3x, name 3 ordered pairs that would belong to the relationship. So they're letting us choose anything. Good, because I'm going to choose some easy numbers. And I know that it's ordered pairs, so I like to label them X, Y, X, Y, X, Y. And I would put 0, 1, and 2. Because they're little numbers and they're easy numbers. So if I take this, Y is equal to 12 minus 3 times 0. Well, 3 times 0 is 0, and 12 minus 0 is 12. So I put 12 right there. And then do it again. 12 minus 3 times 1 this time, because X is 1. Okay. So 12 minus 3 is 9. You see? And then we've got 12 minus 3x. So 12 minus 3 times, instead of x, we're going to put 2 this time. 3 times 2 is 6, and 12 minus 6 is 6. See how I followed my order of operations there? You got to multiply before you subtract. Don't forget that. Okay, so that's all of page 9. We're going to go to page 10 and hope that there's not anything too hard on page 10, because guys, most of the time I kind of work this stuff out before I look at it and do it with y'all, but this time I'm winging it, so that's okay. We can handle this. Problem 5, write the equation and verbal description that represents the linear relationship shown in the table below. X represents the height of the parallelogram. Okay, so we're going to put height, and Y represents the base. Okay, so show your answer to support your work. So we're going to do the same thing that we did last time. We're going to find our rate of change, because that's what M is, and we're going to plug in some numbers and we're going to figure out what this stuff is. Alright, so our change in Y. So M is the rate of change, and change in Y divided by the change in X. From 5 to 7, that means our change in Y is 2, and our change in X from 3 to 4 is 1. Okay, from 5 to 11, and I'm just randomly choosing stuff to double check and make sure that the relationship is a consistent relationship. We want it to stay the same. So from 5 to 11 is 6, and from 3 to 6 is 3. Consistent so far. How about from here? 7 to 23. 23 minus 7 is 16. And from 4 to 12, that's 8. So all of them, when you divide them out, guys, gives you 2. So we know that Y is equal to 2 times X plus or minus something. So if I use these numbers here, let's see what I get. I'm going to use 5 for Y, and I'll say 2 times 3 plus what number? Ooh, okay. Well, 2 times 3 is 6, plus negative 1 gives me 5. So I know that this is negative 1. And so I can write this, instead of plus negative 1, I could say Y equals 2x minus 1 also, because that's the same thing. When you're adding a negative, subtracting a 1, either way is okay. Okay, so I'm going to take this equation and I'm going to put it over here. So Y equals 2x minus 1. And if I put that x values into this x, 2 times 3 minus 1 gives me 5. And 2 times 4 instead of x minus 1 gives me 7. And 2 times 6 is 12 minus 1 gives me 11. And 2 times 12 minus 1 gives me 23. Oh my word, we have figured this stuff out because it checks. Okay, now the fun stuff. It asks us to write a verbal description that shows the relationship between the height and the base of the parallelogram. Remember, the height was y, and the base of the parallelogram, oh, I said that backwards. The height is x, and the base is y. Okay, so we know that 2 times the height less 1 equals the base. So that right there is the verbal description. We're just taking this equation and turning it into the words. Okay, so 2 times the height less 1 or minus 1 or 1 less than 2 times the height, I could have said it that way. There's lots of different ways that you can write this, is 2 times the height less 1 is the base. I know that sounds weird, but whatever, close enough. Told y'all I'm winging it this time. Problem 6. Write a verbal description that represents the linear relationship shown in the equation below. X represents the number of red beads in a bag, and Y represents the number of green beads in a bag. And so let's see. It says Y is the number of green beans. So Y is green, and X is red. This is the number of beads in a bag. So the number of green beads in a bag is 4 times the number, no, we're going to put it 2 less than 4 times the number of red beans. I am stuck on beans. It's beads. Don't ask me where beans is coming from. Maybe I need to eat some beans. I don't know. Okay. So, pretty good. Let me pat myself on the back. I did a good job on that one. How about this one? The number, remember, Y is green, of green beads is 2 times the number of X, or red beads. 2 times the number of red beads. I'm doing pretty good on this one. Yeah. And then, remember, Y is green, X is red. So we're going to put the number of green beads is 12 more than 3 times the number of red beads. That look good to y'all? Looks good to me. Okay, so the only thing that came out kind of wonky is this stuff, but it still works. So I'm not going to change it. I'm not going to redo the video. It looks good. This is page 9, this is page 10, and we are through. And guys, remember that just because I put these as the answers doesn't mean that those are the only possible answers. There's a bunch of different ways that you could say those things and still mean the same thing. So I hope that this helped y'all to understand this stuff, and y'all have an outstanding day, and I will catch you next week. Okay. Where's the stop button?